Hello everybody, this is Mr. Joseph. Today we are going to multiply and divide rational expressions. Multiplying and dividing is really not different from just factoring and simplifying, and I'm going to show you this in this video today. So when you do these problems, you have to call each term out. So for instance, when I look at this first term, x squared minus 2x minus 24, the method for this is sum and products. Sum and products. You know, what two numbers multiply to negative 24 and add to negative 2? I'm going to call this one out, sum and product. I'm going to start just saying S and P. When I look at the next two, I see this is a lot different. I'm like, interesting. So I see that they have terms in common, so I'm going to call this greatest common factor and call this greatest common factor. So by calling them out, I'm calling out the factoring techniques or simplifying techniques that I'm going to use for each one of the trinomials and binomials. So for the first one, what two numbers multiply to negative 24 and add to negative 2? If you're still struggling with this, it's okay. You just have to write a list of all the numbers that multiply to 24. And you can also use a calculator to help you if you need it. So 1 times 24, 2 times 12, 3 times 8, 4 times 6. I mean, you could just take 24 and start dividing it by numbers. So for instance, if you did 24 divided by 4, you see that you get 6. So 4 times 6 is 24. Whatever the case is, whatever works for you, you just have to use it. And here we see that 6 and 4 are 2 apart, so this is most likely our answer. And in order to get a negative 2, it's going to be negative 6 and 4. So that's the process that I'm going through when I'm doing these problems. I'm not going to show this work for every problem, but I just wanted you to know how I'm thinking about them. So I'm going to go ahead and I'm going to erase this, and I'm going to write my answer. So I have x minus 6, x plus 4. And then for the bottom, I have two numbers that multiply to negative 10 and add to 3. I hope that you see that's x plus 5, x minus 2. How do I check? 5 times negative 2 is negative 10. 5 minus 2 is positive 3. Then I keep going. And here, I notice that both 3x squared and negative 6x both have a 3 in common and have an x in common. So I'm able to factor out a 3x. And 3x times what gives me 3x squared? Well, 3x times x. 3x times what gives me minus 6x? Well, that would be minus 2. And you can always distribute and check to see if that is true. On the bottom, I have now x cubed and 4x squared. So I'm going to factor out an x squared. And then x squared times x gives me x cubed. X squared times 4 gives me 4x squared. So once you get done with this part, you try to divide terms out that are the same. And it doesn't matter if it's on the top right or top left, because it's multiplication. We can just put everything in the numerator together and everything in the denominator together, but we're just lazy. We don't want to write everything right beside each other, since we can just do this. Because x minus 2 divided by x minus 2 is 1. We're able to divide that out. X plus 4 divided by x plus 4 is also 1. We are able to divide that out. And then here we have x divided by x squared, which, if you remember your exponent rules, will technically be x to the power of negative 1, but when you flip it, you end up with an x on the bottom. So we're left with x minus 6. So this comes away and this goes away. And you're left with a 3, and I'm just going to put that in front. And you're left with an x, and you're left with an x plus 5. Multiplication is beautiful because of the commutative property that, I can write this 3 behind or in front. It doesn't matter since we are multiplying. I hope that makes sense. And if you are having trouble with x divided by x squared, you can also think about it like this. X divided by x times x. These x's will divide out, and that's why you have a single x on the bottom. That's another way to think of it. And this is our final answer. All right. We move on to the next one. And you should be happy because you should just say S&P, S&P. And 2 more times, S&P, S&P. So sum and product. So we're excited about that. However, we're not going to even deal with that yet because we notice that we have a division problem. So the first thing that we need to do is we need to go ahead and change it to a multiplication problem and take the reciprocal of our second term. Because when we divide, that's the same thing as multiplying by the reciprocal. So that's the first thing I want you to do so you don't have to worry about it later and you have no risk of forgetting it. And then from here, you just factor. And once again, when it comes to speed, it's just practice. What two numbers multiply to 20 and add to 9? Well, that's 5 and 4 because 5 plus 4 is 9. 5 times 4 is 20. What two numbers multiply to 28 and add to negative 11? Well, that's going to be 7 and 4 that give me 11, but I need to multiply to a positive number, add to a negative number, so it's going to be minus 7 and minus 4. What two numbers multiply to negative 4 and add to negative 3? Well, that's minus 4 and plus 1. And what two numbers multiply to 15 and add to 8? That's 5 and 3. This actually starts becoming fun once you start getting comfortable with your multiplication tables and realizing that it's sum and product. So I was able to divide out x minus 4. I was able to divide out x plus 5. And that's all I have left. So I'm just going to write what I have on top. And students always get confused at this step because they're like, am I done? Do I need to multiply them out? And what I say is, you're done. Because even if you did distribute and you get like a trinomial divided by trinomial, it's not more simple, right? The whole point of this factoring them was to divide out the common terms, and we have accomplished that. In our last example for today is going to be another multiplication problem that incorporates some different type of factoring techniques. So we have this one right here. So we'll talk about that. We have this one right here. We'll talk about that. And I believe we already discussed this other one, this 6x squared minus 96. This is GCF. So we know that this is greatest common factor. This is the one that we might forget. This is called difference of perfect squares. So that's something we need to refresh on. And this is just a smaller greatest common factor problem. I know that it looks like it can't be simplified, but actually it can. So let's go ahead and let's take care of these. First thing is x minus 3, just leave it alone. There's no need to do anything to it because it's already simple. We can't take anything out. We can't factor it anymore. 2x minus 8, well, they're both divisible by 2, so I can take a 2 out, and I'm left with x because 2 times x gives me 2x, and I'm left with a minus 4 because 2 times negative 4 is negative 8 times 6 and 96. What number do they both have in common? Well, they have 2 in common, they have 3 in common, but the first number I'm going to take a guess at is 6 because I want the biggest number. So is 96 divisible by 6? Well, let's try it out. If I do 96 divided by 6, I'm going to go old school on y'all. 6 goes into 9 once, so I get a 6. And I do 9 minus 6, I get a 3, and I drop the 6. 36 divided by 6 is 6. So 96 is divisible by 6. So when I take a 6 out, I'm left with x squared minus 16. And then on the bottom, when we have a difference of squares, the question that I'm asking is, what two numbers multiply to negative 9 and add to 0? Well, they both have to be the same number and opposite signs. So that's why we're going to get x plus 3 and x minus 3. And sometimes when we do this, we simplify it, but then we run into something that we have to simplify again. And then I hope that you notice that x squared minus 16 is something that we can factor again. So before even crossing out anything, I'm just going to continue to factor. And I'm going to copy everything else the same. And I got 6 times x minus 4, x plus 4, and I have an x plus 3, x minus 3. And now I look for terms that I can divide out, and I have an x minus 4, x minus 4, x minus 3, x minus 3. And I have 6 parentheses x plus 4 divided by 2 parentheses x plus 3. And I know a lot of you are wondering, can I do this? Can I do 6 divided by 2? Yes, you can. So 6 divided by 2 is going to be 3. And you get x plus 4 over x plus 3. Do you need to simplify? No. Because even if we did distribute the 3 or give us 3x plus 12, it doesn't help make it smaller at all. So that's it when it comes to multiplying and dividing. It looks intimidating. It looks long. Like, look how much work I did for this question. But it's actually just factoring and dividing. Like, that is it. And just remember, on division problems, please change it to multiplication and do the reciprocal.